Alright, this is more or less what this is going to look like. Nothing here is to scale on sloppy CAD. These 4 holes, those are the mounting holes that go in those angle iron braces on both sides. The first one's in 3/4 and then goes 6 3/4 to the other side. The slots, I test fit with the existing holes, setting the new motor on there, putting the belt on. 2 1/4 to the center of the slot is good, and then the next slot needs to be 2 5/8 away. These are going to be 3/8. Those mounting holes will be 25/64. Those they're the ones that are there except 3/8 bolts, so we'll just give ourselves a little room. The motor, it's in between 1/4 and 3/8, so we'll just go 3/8 on the slots, give ourselves some space to move around and angle things a little bit. I mean, you shouldn't have to, but it gives you a little room. Going to leave 1 inch in between the slots so that this can be more of a stiffer monolithic piece. If it's just one long slot, it's not going to be very strong, and I do want some strength to it. These slots will be 4 inches. That's about that's how far in between the mounting holes there are, so that's all the travel you're going to get out of this anyway. So that's more or less it. So I'm just gonna dicom this thing up and mark it just so that I can see that when it goes in the milling machine we're getting holes in the right spot. I learned this toilet paper trick from some other YouTube guys. It's not too bad of an idea. I've never tried it before, but it does seem to work pretty nice for spreading this layout fluid out. So I'll go with that. I like it. I'm a bit sloppy, so, and I want that darker. Oh yeah, that's better. Get some of that picked up. And if you really want to mess with somebody, lay that in the toilet when you're done. They'll really think you got something wrong with you. Oh man. Alright. I need my tape measure. Alright, so those holes, they're 4 3/4 apart. So we could just say the first one goes at somewhere near 3 1/2, and that's supposed to be Alright, that's more or less what it ought to look like. I'm going to draw this up in the computer and write the cam for it, and we'll throw it in the mill and cut it out. Hey, let's check something first. Well, something ain't right there. That's 2 3/4, not 2 5/8. Haha. How did I get that screwed up? Okay, we're going to draw this up in Fusion 360 so we can do the cam on it. One thing I like to do for my hole patterns is actually use a rectangle to define them, especially when there are 4 holes. This is a construction rectangle, so it won't actually be used to extrude anything, but we can use it for locating other elements, which is really, really useful. So we want that hole to be in 3.5 inches. So now it will be, because we can put a hole on that point. The other thing down here, I'm looking at this is the front of the press. That should be 5/8. They're 6 3/4 apart. That's an 8. Why did I type an 8? Nice. And then 4 3/4 for that. So now we'll have all of these holes located based on this rectangle. If you ever want to change any of the distances, so I could make, this one 6 inches instead, and I would just push these holes over. So that keeps the parametric thing going with the CAD here, so that all of these things will be the same. That hole is supposed to be 25/64. Then I just need to create 3 more of those. Okay. We'll just drop those right on each of their individual points. Okay, I forgot to uncheck my construction box. So I'll just go and get these guys selected. Make them real holes. Now those will extrude when we extrude the part. Alright, now the same thing we'll do for the slots. But that's gonna be a little different. I'm gonna use a rectangle to model each slot, but then I'm gonna also model a rectangle to locate essentially what will be the center of those slots, because I'm gonna draw them with center rectangles. That'll again allow for moving those slots around really easily and keeping it parametric. The tempting thing to do here is to just come in and draw a rectangle, preferably one that's not construction. That's funny, I can never get that to remember to stay turned off. Rectangle, not construction. And then dimension it to the side and this side, and then actually go ahead and use the rectangular pattern, and then that will, you can say create 2 wide, 2 high, and set the dimensions. I don't like doing that because it just creates, in this case, it would create 3 more rectangles that are completely disembodied, and they're not connected to this one at all. So they're not parametric at all, so you can't move them around. And actually, I'm doing this recording here after the fact. You haven't seen it yet, but you'll see when I first start cutting out the part, the 2 slots here, the pre-drill holes, they're actually in the wrong place, and the motor wouldn't actually be able to bolt down to the plate if I left those alone. If I had to use just a mirror pattern or whatever that was, then those holes wouldn't be connected, and I have to move them manually and redraw them. So what I'm going to do instead is actually create a rectangle for them, and this one will be a construction rectangle. and it is going to set basically the centers, where the centers of my slots are going to be. Okay, so in order to do that, I know that the center of that hole, or that slot, needs to be 2 1/4 off this side. I know I wanted an inch off of this side, and I know the slot is 4 inches long, so that means that it needs to be 3 inches from this side to get that center. Okay. Then, since each slot is 4 inches long, again 2 inches here, an inch gap in the middle, another 2 inches to the center of the next slot. That makes these 5 inches wide. Okay, so now I have a complete construction setup here for actually building what I really want for my slots. Okay, so now I'm going to go up and I'm actually going to create a center rectangle. Make this not construction because I want this to extrude. I'm going to start here. I'm actually going to bring it out and say I want my 3/8 by 4-inch rectangle. Okay. So I'm going to move that dimension around where it's easier to see. Same with this one. Okay. Now I just need to repeat this for my other 3 slots. So there's my 3 guys. Now I can take and dimension this. I'll just make it equal to that one. Same with this dimension. Equal to that one. The only thing I don't like about this method is you end up seeing a lot of extra dimension lines that you wouldn't otherwise. But now I have a fully parametric setup on these, so if I decide I need, slots that are 3/4 inch wide instead, now they are. Their centers are still exactly where they were before. They're all still spaced about right, but now I could use larger bolts in this exact same hole. Say if I didn't want the slots as long, I can make them 2. Now they all got smaller. So this makes it a lot better for resizing and moving these things. All right. Now, last thing we need to do, in order to cut these slots, I'm going to actually take my end mill and plunge it almost all the way up to the tool holder, so that it's really, really short. That makes it very rigid, and I can just cut this slot. This is 1/4 inch material, but it'll just cut right through there. In order to do that, I'm going to need a pre-drill position. So I'm going to go ahead and bring a circle in here. And now that's going on the construction line for the first construction rectangle that we created. See, make sure, yep, we're not drawing construction circles, so that's good. So I'm just going to go ahead. That's automatically creating a coincident constraint with that line, so that center of that circle will stay on that construction line. Okay, and now I can zoom in here and I can set some tangent constraints. So I don't even have to dimension these circles, which is really nice. I can just say to make these circles tangent with these lines, and they dimension automatically. Alright, so those all should be put together. So now we can go ahead and extrude this part. Okay. Now I've done something wrong here. This is going to make this really, really difficult to get those pre-drill holes, which is I drew them on the sketch that we were originally using to extrude. Since they didn't actually change how the features looked, they didn't do anything. So I actually didn't need to create those 4 holes there. I need to do them now. Okay, so to put those circles in place, we're actually going to sketch on this face instead. Alright, so we'll create a sketch on this face. We're going to zoom in here and throw a circle in. And then we're going to constrain it. So we won't actually have to dimension it at all because we'll make it tangent to each of the sides of this rectangle. Now our circle is fully constrained, and that gives us a pre-drill position so that we can actually get in here with our end mill without having to plunge it. We can just plunge a drill instead. So you just go through the rest of them and do the exact same thing. The nice thing about using this tangent, if you ever go resize your circle or slots on the original sketch, these circles will automatically resize as well. So that's one of the challenges with doing this design, is figuring out how do you actually get some of these elements in place that you need to aid you in doing your CAM so that you can do your machining correctly. And often I've found just drawing an element on a face later is the way to go. So let's actually try that. Let's go in and edit this sketch. And let's make these slots 3/4 again. Okay. Stop sketch. There. Now our holes are automatically bigger because they're tangent, but now we're interfering with those holes. That's funny. So we wouldn't want that, obviously, but you can see how that works really, really well to allow you to resize things. All right. So now we've got our plate. We got our circles to aid us in doing our CAM. So now we can actually go over and do our CAM. Okay. So let me get my setup in place here. I don't want any stock. Relative size, yeah, we'll just do 0, 0, because there isn't any stock. This thing's already the right size. I want my origin to be back here. That's the right orientation, so we're good to go. All right, and then we're going to add a drilling operation. I use a center drill to do all my spotting. And then we can choose our geometry. And here's where it gets interesting. So now I can't pick those. So I can do points instead. And these holes will still get picked based on being points. And then I can pick the points on these pre-drill holes so that I can make my slots. Alright, there we go. So let's go ahead and run through a simulate real quick. I like to show stock, and I hate this mirror. I like the ceramic. I'd like to be able to default that, but I haven't figured out how to do that. Hey, wow, that tool orientation was not correct. Look at that. Alright, so let's go back to the setup. What's wrong with that? Oh, yeah, X is pointing up, not back. I didn't see that right. Alright, so let's edit that guy. And change this. Yeah, we'll choose our Z and our X. So we'll make this plane as our Z. And then this line is our X. Flip that guy. There we go. That's what we want. So this ought to work a heck of a lot better now. Recreate that tool path. And let's simulate and run. Alright, so that's good. Excellent. I'm not going to show the rest of this cam design. What I wanted to show, I don't even have the depth right on this. That's funny. I am not trying to do a tutorial on how to do CAD and CAM here. What I wanted to show was this planning ahead and making these holes so that you could actually do your pre-drill, because that's something just a little bit different. Let's put our depth here just for fun. Alright. There we go. That's making our holes in the right spot. Good deal. Alright, so we'll go ahead and switch over to the CNC. I'll show next, I believe it's going to be doing the dry run on the machine to see how you can walk through these parts and do a dry run and set up safely. So that'll be the next video.